In this video, we'd like to introduce the Metra VM31 Human Vibration Analyzer. VM31 is easy to operate and features a wide range of functions. Its luminous OLED display and 7 buttons form the control panel. The VM31 is powered by 3 micro AAA batteries or accumulators. The VM31 measures hand, arm, and whole body human vibration, as well as acceleration, velocity, and displacement. Additionally, the instrument measures frequency analysis. Human vibration impacts on the body from outside. Hand, arm, and whole body vibration are differentiated. Typical sources of hand-arm vibration include construction equipment and handheld power tools such as chainsaws, angle grinders, hammer drills, and breakers. Whole body vibration also impacts on the driver's seat of forklift trucks, military vehicles, construction and agricultural machinery. Why measure human vibration? Vibration is a common cause of occupational illnesses. Vibration impacting on the hand-arm system causes degenerative changes to bones and joints, circulatory disorders, and neurological diseases. Vertical vibrations in the sitting position can lead to degenerative changes to the spine, such as slipped discs. Employers are obliged to monitor the effects of vibration on their employees. Similarly, manufacturers of working tools are required to measure and publicize the vibration emissions of their products. For this purpose, guidelines and standards exist. In Europe, the EU Directive 2002 is authoritative for employers. It determines the trigger value for hand-arm vibration at 2.5 meters per second squared and an exposure limit of 5 meters per second squared. For vertical whole body vibration, these are 0.5 and 1.15 meters per second squared. The specifications and provisions for measurements are stated in the following standards: ISO 5349 for hand-arm vibration and ISO 2631 for whole body vibration. ISO 8041 specifies the requirements for human vibration measuring instruments. We'll start with a hand-arm measurement using VM31. For this, you'll require the triaxial accelerometer included in the VM31 HA kit. Metra also offers accessories for attaching the sensor to handles. The handle adapter, type 143, is pressed on by hand. Alternatively, you can attach the sensor using the adapter type 141 and cable tightening straps. The sensor should be located as close as possible to your hand without impairing your work. Now we'll switch on the measuring instrument. The electronic data sheet of the sensor, TEDS, is read and the sensitivities are automatically registered. This helps to minimize the danger of mix-ups or setup errors. Now we'll select the settings for hand-arm vibration. First, we'll press the menu button and select Human Vibration, Hand-Arm. The instrument selects the weighting filter, WH, for all 3 directions of measurement. The measured parameter is the interval RMS. This refers to an RMS value, which is averaged over the total measurement duration. The VM31 displays the 3 axes values for X, Y, and Z. These values are used to determine the vector sum AW. The vector sum is the parameter relevant for risk assessment. Additional information about the shock content is ascertained from the maximum transient vibration value, MTVV. Now the measurement can begin. The hand of the test person should be located at the handle of the running machine. Press the right arrow button to start the measurement. In the upper right corner, a timer displays the measurement duration. The timer will remain red for up to 30 seconds. This is the minimum measurement duration for hand-arm vibration. It is nevertheless important to always measure for long enough to obtain a representative of the work process. As a consequence of the mean value calculation over the total measurement duration, the interval RMS values fluctuate more severely at the beginning. Towards the end of the measurement, the values should scarcely change. If the measurement is finished, press the Save button. You may also add a comment text to the saved measurement. We have now measured the vibration for a typical working procedure. For a health evaluation, we need to calculate the corresponding vibration exposure during an 8-hour shift. Based on the measurements and the duration of the working procedure, the daily exposure value, A8, is calculated. The required calculation is carried out externally in an Excel worksheet. Metra provides a corresponding macro file which transfers the measurements from the VM31 memory to Excel. Connect VM31 to your PC via the USB cable provided and switch it on. When connecting up for the first time, you'll need to install the instrument driver. The Excel file contains 10 worksheets. Select Import. In the table header, you'll find various buttons. Click on Import Measurements. Now the USB COM ports will be searched to locate VM31, and the stored data will be transferred to the table. In the columns next to a running number, you'll find the date, time, a comment, data related to measuring and display mode, and to the filter. Following these, there are columns for the measurement values X, Y, and Z. And under B and C, the vector sum and MTVV value. Now we'll select the measurement values which will be applied for the health assessment. In this case, only the hand-arm values with the assessment health will be taken into consideration. Click on Transfer Selected Data to Daily Exposure Worksheets and switch to the worksheet A8 RMS H to A, where you'll be able to find the selected measurements again. Next, we'll assign the measurement values to persons and activities using pull-down menus and enter the average duration of each activity. To calculate the daily exposure values, click on A8 Calculation. The results are shown in the right half of the table. The calculations are compared to the threshold values of the EU directive and colour-coded. The A8 calculation can be applied to the data of several persons simultaneously. The Excel macros also assist you with the creation of standardized reports. You can enter information about the measuring conditions, sensor attachment, tested machines, etc. The VM31 data is already included in the report. The Excel environment offers great flexibility for further processing your data. With this last step, the measurement and analysis of hand-arm vibration is now complete. Next, we'll take a look at the measurement of whole body vibration. For measuring whole body vibration, the seat pad accelerometer type KB103 SVD is provided. The KB103 SVD is a triaxial accelerometer which is built into a flexible cushion pad. It also contains TED's transducer electronic datasheet, with which the VM31 automatically registers a change of sensor. Seat vibrations are usually measured at the driver's seat, in this case of a forklift truck. In the VM31 menu, we will now select Whole Body Vibration and Health Assessment. In this operating mode, different evaluation filters and weighting filters will be applied for each measuring direction. The filters WD for XY and WK for Z will be used. The display shows the three interval RMS values. In addition, the vector sum, AW, and the maximum transient vibration value, MTVV, are displayed. Alternatively, VM31 can display whole body vibration as a vibration dose value, VDV. This is an RMS value to the fourth power. This method is more sensitive for impulsive vibrations. Toggle the display mode by pressing the left arrow button. Press the right arrow button to start the measurement. The timer in the upper right corner displays the measurement duration. The timer remains red for 2 minutes. This is the minimal measurement duration for whole body vibration. It is nevertheless important to always measure for long enough to obtain a representative of the working procedure. When the measurement is finished, press the Save button and add a comment. Calculation of the daily exposure value, A8, is done in Excel. In Import Worksheet, the measurement values are read from VM31. For whole body health assessment, appropriate values are selected and transferred to the worksheet for calculating the daily exposure value. Depending on whether you have measured RMS or VDV, go to the relevant A8 worksheet. Here you can assign the measurement to persons and activities using the pull-down menu. Furthermore, add the duration of the activity for a representative 8-hour day. The daily exposure value, A8, is displayed and compared with the threshold values of the EU directive. A measurement report is prepared using the measured values. In addition to health risk assessment of whole body vibration, the VM31 is suitable for measuring seat effective amplitude transmissibility, SEAT. Seat value is the ratio of the vibration experienced on top of the seat and the vibration that one would be exposed to when sitting directly on the vibrating floor. Both vibration magnitudes are measured without frequency weighting in the vertical direction Z only. Seat values are widely used to determine the vibration isolation efficiency of a seat. For seat measurement, the VM31 has a fourth channel to which a uniaxial accelerometer, KS78B10, is connected. Besides measuring vibration for assessing health risks to workers, VM31 is also suitable for carrying out comfort evaluations of whole body vibration. For example, in buses, trains and buildings. For this purpose, the instrument has all the necessary weighting filters. A special application in the area of comfort evaluation is the measurement on ships. The specifications are stated in the ISO 6954 standard. For this operational purpose, we recommend using the KS 823B high sensitivity triaxial sensor with VM31. Accessories such as a tripod base and a magnet adapter facilitate the measurement on ships. VM31 has the weighting filter WM as required by ISO 6954. If required, VM31 can save measurements in all operating modes at 1 second intervals. The active data logger is indicated in the upper right corner of the measurement display. The log data can be transferred to Excel via the USB interface. VM31 also allows you to carry out simple frequency analysis. This can be helpful for identifying dominant vibration frequencies and their sources. Select Frequency Analysis from the menu. The instrument will display a 127-line FFT of the 3 measurement directions X, Y, and Z, which can be distinguished by their colors. A choice of 3 frequency ranges are available to choose from. The main frequency and its amplitude are displayed in the diagram. You can gauge the spectrum using the cursor. The spectra can also be saved. The VM31 memory can save up to 10,000 measurement values, 1,000 frequency spectra, or 100 data log records, each containing up to 32,000 values. The stored values can be transferred to an Excel file or viewed on the instrument. For general vibration measurements with up to 4 channels and a maximum bandwidth of 2 kHz, VM31 offers measuring ranges for acceleration, velocity, and displacement, with various high-pass and low-pass filters. VM31 is available in the following kits: VM31 HA for hand-arm measurement, VM31 WB for whole body measurement, and VM31 HA WB for both. Thank you for your attention.